Hello, in this video, I will explain to you on how to find I0 here. I0 is the voltage that pass through this 10 ohm resistor using node voltage method. So our goal is to find I0 and we need to use the node voltage method. Okay, let's do it step by step then. Voltage method, and then the first step will be to label all the nodes, right? Label all the nodes and also extract some information that is available from the circuit. Label all the nodes. Okay, and the first node that we need to know is the reference node. Okay, let's set this here as our reference node. So this one will be our ground, reference node, or our ground, and that means that the voltage here will be 0. Okay, good. But then if this is 0, we can get the node here, right? Because the difference between this node and this node has to be the magnitude of this voltage source, right? So that will be 80 volts. So we will have 80 here, right? Or yeah, the voltage here in this node is 80 volt. Good. Because of this voltage source, the difference between the positive terminal and negative terminal has to be this 80 volt. Good. And this node and that node is unknown. Let's name this node here as node A. So the voltage here will be VA. And then here, let's name this node here as node B. So the voltage here will be VB, right? Good. And I think we have done our first step, which is labeling all the nodes and also extracting some information from the circuit. Okay, and then the second step that we need to do is to assume the direction of the currents. Assume the currents direction. Okay, let's see here. We have this, maybe goes there, and this also goes there. But for I0, I just follow this arrow here. Okay, and then for this one, I will goes like this, and I also goes like this. Okay, and that is the second step. We have assumed all the direction of the currents. And the third step that we need to do is to do KCL for each unknown nodes. Okay, do KCL at all unknown nodes. Okay, we have two unknown nodes, right? VA and VB. So we need to do KCL at VA and at VB. Let's do exactly that. So the first KCL that we need to do is in the node VA. KCL at VA. KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Okay, here, let's see at node VA here, there is no current that goes in, right? All the currents goes out. This goes out, and this also goes out. Okay, so I will have 0 as the current that goes in. And that will equal to this first current here is the current that goes out. And this current is VA minus 80. So I will have VA minus 80. Okay, and then remember that this is a voltage. We need current, so we divide it by the resistance between them. So I'll have 5. So VA is where the current comes from, 80 is where the current goes to, and 5 is the resistance between them, right? Okay, now let's move on to the second current that goes out. And this current here is VA. VA is where the current comes from, minus VB. VB is where the current goes to, divided by the resistance between them. So I will have 10. Then I will have plus another current that goes out here. I will have VA. VA is where the current comes from, minus, this is a reference node. The voltage here will be 0, so I will have VA minus 0. So VA is where the current comes from, 0 is where the current goes to, divided by the resistance between them, which is 70. Good. Now let's multiply both sides here by 70, I think, to get rid this denominator, right? Okay, so on the left hand side, I will have 0, and I will have 70 VA. And then minus, not 70, that will be 5 and 70 will cancel into 14, I think, 14 VA. And then minus 14 multiplied by 80. What is it? 14 multiplied by 80. 1120. Okay, I will have 1120 here. Then plus 10 and 70 will cancel into 7. So I will have 7 VA minus 7 VB. Okay, and then 70 and 70 will cancel each other. So I will have plus VA. Good. Now let's do some math here. 14 plus 7 is 21. 21 plus 1 is 22. So I will have 22 VA. And then I will have minus 7 VB. Okay, and that will equal to 1120. And I think nothing more that we can do here. Let's set this as equation number 1. Okay. And now let's do another KCL, but this time at VB, right? Because we already done at VA. Okay, maybe let's clean this a bit. Okay, let's do our second KCL here. Now let's do KCL at node VB. Okay, KCL said that the sum of the current that goes in will equal to the sum of the current that goes out. Good. Let's see at node VB here. All the current R goes in. Okay, so let's work on the current that goes in first. So I will have AT here. AT is where the current comes from, minus VB, where the current goes to. Okay, and then divided by the resistance between them, I will have 5. Good. And now I will have this one here. So we will have plus, I will have VA minus VB divided by the resistance between them, right? So I will have 10. VA is where the current came from, VB is where the current goes to, and 10 is the resistance between them. Okay, similarly for the last current here, I will have 0 here. 0 is where the current comes from because it is the ground. Minus this one here, I will have VB and divided by the resistance between them. So I will have 12 here. Okay, and I think that's all for the current that goes in. Now for the current that goes out. There is no current that goes out, so I will have 0 here. Okay, and let's multiply both sides here by 60, I think, to get rid all of the denominator, right? So I will have 5 and 60 will cancel into 12. And 12 multiplied by 80, that will be 960. Okay, I have 960, then minus 12 VB. Okay, and then 10 and 60 will cancel into 6, so I will have plus 6 VA minus 6 VB. And 12 and 60 will cancel into 5, so I will have minus 5 VB. Okay, all of that will equal to 0. Good. Now what can we do from here? I think we can do some math here. Let's move this 6 VA to the right hand side. So I will have minus 6 VA. And then I will have minus 12 minus 6. That will be minus 18. Okay. And then minus 18 minus 5. That will be minus 23. So I'll have plus 23 here because I move it to the right hand side, right? and the only thing that left is 960. I will write it like here, 960. Okay, this is equation number 2. Okay, now we have equation number 1 here and equation number 2. We have 2 equations and 2 variables. That is a linear system equation. We can solve that using linear algebra, right? So the first step will be solve the equations. Solve the node equations. However, I will do the fastest way here, which is to use calculator. Why? Because usually in circuit analysis, you can use calculator, right? So why don't we just use calculator? Okay, so we will have this calculator. Let's set this up as equation solver, which is number 5. 2 variables is number 1. And now what can we do is just to plug in the coefficients. So I will have 22 and then minus 7. Okay, and then the result is 1120. Good. And now the second equation, I will have minus 6, 23, and then we will have 960. Good. So I will have our PA, which is 70 here. Okay, we will have PA is equal to 70. And the unit here will be in volt. Good. And then what is VB? VB is the Y value, which is 60. Okay. VB is the Y value, which is 60 volt. Okay, now we have our PA and our VB. And it is an important value, but it is not the thing that asked by the problem. The problem asks about I0. Okay. Now we can calculate I0 from this, right? Because I0 is just VA, where the current comes from, minus VB, where the current goes to, divided by the resistance between them, which is 10, right? So we'll have 70 minus 60 divided by 10. 70 minus 60 is 10. 10 divided by 10 is just 1. So I will have I0 here is equal to 1. And how about the unit? Because this is in volt, this is in ohm, this will be in ampere. Right? So we will have this is the final answer of this problem. So I0 here is equal to 1 ampere. And that is our final answer for this problem. Okay, thank you for watching. See you in the next video. Bye bye.